Good evening. Good evening, Marie. Again, thank you to Sappy. We're going to start right up at the very beginning and saying that you're going to have to choose the tree due to ID. And the picture we had was of a bushveld bead bean, and the suggestions were quite important to follow, because if you try and ID a tree that doesn't fit the data that is in the app, you're going to struggle. First and foremost, it must be a tree or large shrub able to grow to 3 meters or more within the borders of South Africa. That means it's an indigenous tree. Next week, we'll cover alien invasives, encroachers, and indigenous, and how they're different, and exotics. But indigenous means they originally grew here when the first records were kept. We suggest that you always choose a mature tree, if you're clever enough to know what that is. I make lots of mistakes. It's not always easy to know. But if it's a nice big tree, you know, sort of growing with quite a thick stem, then it's a mature tree. And if possible, start with trees that grow naturally in a wild environment. Trees that are planted, so not naturally in a wild environment, can be structurally different, even if they are indigenous. If, for example, there could be much more rainfall than it's used to, it can be colder, there could be frost, the soil might be the wrong soil, and that really affects the shape, the size, and all the textures of the tree. Trees planted anywhere, schools, parks, gardens, roadsides, farms, may not even be indigenous, and they will not follow the location rules that you're going to insert to your app. This picture here is of the knobbly fig, Ficus sansevieria, in Olifantskamp, Kruger. You can see the beautiful Olifants River behind the picture. Here's why it's called knobbly fig, because the old fruit stalks turned into little knobbles. Now, this tree was planted by Piet van Wyk in the camp at Olifants, and it's thriving there, and you can see it literally where the restaurant is. Now, many years ago, Professor Kevin Bolko told me that the hardest thing about teaching tree ID to anyone new was to help them to understand how they have to learn to focus on each and every word in any text or instruction. Each word means something. When you look at any actual species, you need to learn to see and focus on the different parts of the plant, because each part is a separate element. Professor Bolko always tells the story of this num-num, the Carissima spinosa. And his story was that he pointed it out to some students and said, now, what do you see here? Oh, of course, they saw white flowers with pointed leaves, and they saw a red berry, and some of them even saw that there was a little spike at the end of the red berry, and they saw big fleshy leaves. And he said, what else? And no, nobody saw anything else. And he was pretty amazed, because this is also num-num, and you can see it is covered in Y-shaped thorns, two-pronged thorns. If I could go back to show you that the other picture had some two-pronged thorns, but they just weren't that obvious. Now, the important thing, one of the very important things about the app is that the app will actually teach you what to look for. And we're not just being pedantic. My own ability to see parts of the tree has improved exponentially off my Z-base vision impairment. Yeah, it has been 30 years. So, you know, I suppose I've had plenty of practice. And we can say that if it hadn't improved, I wouldn't be sitting here now talking to you for sure. So when we say, what is a tree and what parts do we have to look for? And this is thanks to Sappy tree spotting. And again, I'm going to say, we're not just being pedantic. People don't always use the moment to say, I'm looking at this tree, I don't know what it is, but here's the trunk. What can I see on the trunk? Here's a main branch. What can I see on the main branch? Then a branchlet. These are not just casual words. They mean something. And finally, the twig and the leaves are attached to the twig. So when you read what the text says in a book, or you read what the app says, you need to really focus on what the app's trying to tell you. Now, for example, this is a Hilaria lucida. It is a tree fuchsia. Do you see that these flowers are actually attached to the trunk? This is not a thick branch. This is the trunk. and the flowers actually grow out of it. And any text will tell you that, but not everybody bothers to sort of notice that. I don't know when I first knew that, 20 years after I started looking at trees. And equally, the forest fig, the Ficus craterostoma, the figs are actually attached now. This is to a branch, the branch bearing leaves, or maybe it's a twig, but there's no stalk. It's attaching directly. That's important information. And you actually need to be aware that it's important information and be ready to look for that in the tree. Now, this is something I want to just quickly, I'm going to talk quite fast. If you have a complete app, you will have 1,399 trees listed in it. If you have the evaluation, it will be 155. But just for the moment, I'm talking to the people with the full app, 1399. In those apps, we have a set of trees, 222, that are called difficult species. And that takes the number up to 1399. The difficult species only have a map, like this Aaron's Rod Marvel creeper. They don't have details and they don't have photographs, and they're not searchable. They're searchable by the location, but they're not searchable by any other thing in the app. So quite a good way always, and I'd like you to do this now. So you go to your tree list. So you're on your home screen and you look at tree list and you go into that, and then you click hide a difficult species. And then you'll find that you're dealing with 1,177 species, and it'll tell you show difficult species. But I'm saying we're not going to even mention those difficult species tonight, or possibly even next week. So you don't need to have them on board. They just complicate our lives. So now we go past the home screen and we get to our tree search. And the big red arrow says go to leaves. So please do those 3 steps. And we now have leaves off the tree search. And Marie's very cleverly highlighted the things that we're going to talk about, because now we're going to do a recap on leaves. And we're going to do it in a slightly different way. Simple leaves are partly called simple, not really, but partly, because they are simpler to learn and to recognize as a simple leaf. But funnily enough, it is a great deal harder to ID the species that have simple leaves, because of the 1,117 main trees in the app, 870 of them are simple. Guys, that's 78%. That's an enormous percentage of the number of species out there. So it really does mean that simple, and that all simple have is one blade, remember. Look at the top here. Those are simple leaves, each one with one leaf. Compound are much more complex. There's more information about a compound leaf, and therefore they are easier to handle. Now, I said we're going to do this in an alternative way. It's a new idea, and it should help you to understand simple and compound leaves. So on the left, there's simple leaves. And that means there's a twig at the bottom, the brown thing. Don't forget what we learned last time, the little leaf bud or auxiliary bud at the bottom in brown. And then there's the leaf stalk. And off that comes the vein that carries the nutrients and the liquid into the leaf. And that's the mid vein or the main vein. And the lateral leaves go off sideways on either side of the main vein. Now, over evolutionary time, some leaves, and I'm not even going to try and pretend I can give you the reason why, developed lobes. And you can see that each lobe is around a lateral vein so that it can keep getting fed. Otherwise, it would wither. As evolution progressed, some lobes, they're still simple. They're one blade on one leaf on a twig. The lobes indented further, still each one being provided with nutrients with the vein. And eventually, in evolutionary terms, those indentations went right into the middle, touching the mid-vein, and they developed into one compound feather-like leaves. So now the nutrients come from the twig up what's called the leaf stalk, and then at that point where the leaves join it, the nutrients divide out into that, each of the first two leaves. The nutrients continue up what is now called the leaf shaft. So from the bottom of the first pair of leaflets downwards is the leaf stalk, and from the bottom of where the leaves join for the first time up to the end is called the leaf shaft. And the nutrients can continue up that central leaf shaft, feeding out towards all the leaflets. Now, once it's compound, and it's feather-like, it carries these leaflets. Now, in this slide here, these are a very interesting shape, because getting back to our idea of evolution, each of these leaflets here has got an indentation creating lobes on either side, but that indentation does not go all the way back to the base of the leaf. This is the real one of Bauhinia, often called camel's foot, Bauhinia barkeri. And there are two lobes of a simple leaf. It starts to look as though it's complicated, but just trust yourself. Listen to the words. Look at the pictures. It's one leaf stalk. This should be brown if it was a colored picture. One twig, one leaf stalk, one leaf, because it does not go back to the beginning. Compare this to a mapani, where there's the brown leaf twig. Here's the leaf stalk. And now these two, what were lobes, have actually become two separate leaflets. But this is a compound leaf that's doesn't look anything like a feather. A different kind of compound leaf we see on a marula. And this one, here we see 1, 2, 3, 4, 5 different leaves. Each of these is a leaf. So here's our leaf stalk, and then our leaf shaft, and we've got pairs of leaflets coming off on either side, and one at the end, which I'm about to discuss with you. If we look at these two separate ones, they're both a once divided compound leaf. This one has one single leaflet at the end. You can see on all the different leaves is one single leaflet. This one on the right is a bush boer bean, and that's different. It's got a pair of leaflets, a pair of leaflets, a pair of leaflets, and the drawing doesn't really help us that much, but it's a pair of leaflets. So believe me, in the bush, sometimes it's difficult. You can't see either. So these are very similar leaves. They're both once divided compound. This one is once divided compound with a single leaflet at the tip. This is once divided compound with a pair of leaflets at the tip. Now we take another step in evolution. So these are once divided. Think that this was once one blade, and these leaves divided off following the veins. In the next example, we see what happens if it becomes a twice compound. So in evolutionary terms, we had this once divided feather-like compound leaf with a pair of leaflets at the end. Slowly over evolutionary time, each one of these leaflets divided inwards, as we saw earlier in the simple leaf. And those divisions inwards gave rise to each of these separate leaflets. So now let's go and put some terminology in place. We know that's our twig. In passing, we know that's our leaf bud. So that makes this whole thing one leaf. And there's no growth point at the end, by the way, if you remember. Here's our leaf stalk, and it's now carrying featherlets. The entire leaf is feather-like, but these are featherlets, and they evolved, each featherlet evolved from one leaf. So now, of course, if this is a featherlet, we're going to have a featherlet stalk. Once we meet where the nutrients start dividing to feed the two leaflets, we now have a featherlet shaft. So this is sort of a summary of what we've been saying. It started with a simple leaf, which slowly eroded and created a once compound feather-like with a pair of leaflets at the tip, and that developed lobes to become twice compound feather-like. Here's a real life picture. Thank you, Dr. Robbie Robinson, showing you the fever tree. And we can see here, we always take the length of the leaf from the end of the leaf stalk. So here to here. And I would say that this leaf is give or take 70 centimeters long, maybe a bit longer. So the leaf is 70 centimeters. The featherlet, if we drop it down, is probably about 20 or so. The leaflet, bless its little heart, is possibly 4 or 5 millimeters. Just those who are noticing things, there's a gland, and they're noticing perhaps that the leaf stalk and then the leaf shaft are ridged. There's a ridge around. Oh, what a lot you've still got to learn and look forward to understanding and entering into the app. Now, here's another evolutionary thing along the same sort of base. If the leaf is a heart-shaped leaf like this, quite a lot of those have 3 veins from the base. And in fact, this is 5 veins from the base. Then when the indentation starts in evolution and the lobes, it looks like that. And eventually when the lobes go all the way back to the midline and it actually forms separate leaflets, we then get a hand-shaped compound leaf. And here they are in reality. Wild pear dombea has got the 5 veins from the base. Prickly tree hibiscus, Hibiscus diversifolius, has the lobes, and hello baobab that we all adore has got 5 separate actual leaflets. It doesn't matter whether you are using simple leaves or compound leaves. We've tried very much to use the same terminology so that you don't have to learn separate languages for a simple leaf and a compound leaf. And we did that by calling all of these blades. That's a blade, that's a blade, and these leaflets are blades. So we're going to investigate all the details, intricate details that make this plant what it is by calling this one blade. You're not going to ever want to enter data for all 5. So choose one leaflet or one blade. When we talk about 3 veins from the base, that's on that blade. This one is obviously a single central mid-vein, one from the base of that blade. Yes, I'm handing over to Marié.
Okay, so I'm going to quickly go through and show you the next thing that we are doing, and the next characteristics that we're going to look at is leaf arrangement. And please remember at this stage that we told you that leaves have characteristics with variable ranges. So you will find, and as you go look at the information, that some of the trees might fall into more than one category. So please look at your tree carefully when you are doing leaf arrangement and decide how the majority of the mature leaves are arranged. And we will then start by going to the leaves and selecting simple leaves. So you will see on this picture here, simple leaves. So if you want to open your app and go to leaves, simple leaf, you can follow along. So the red arrow, and then you click on arrangement of woody parts. So we are going to look at the arrangement. You can choose original or botanical. So this one is the options for original. And you will see that there are 7 different options. And remember that your tree might be in more than one category. For example, alternate and rosettes might apply to your plant. And the app filter includes all species in all of the possible options. So if your tree can be alternate with whorls or with rosettes, then that both of these options will be available. Okay, so now go to the next slide. And the first example that we are going to have a look at is alternate. Can you see on the actual leaf, the Salta sinensis, you will see that these leaves are inserted at different levels on the stem. So when you look at each of the leaves, on the opposite side, there is nothing. So it's stem and then a leaf, and then on the next level, there is a leaf, and then on the next level and going on. So these leaves are at different levels. So there's only one leaf per stem area, and the place where leaves are attached are called a node. So at each node, there is only one leaf and they alternate. The second example that we are going to look at is opposite leaves. And as you can see, there are 2 leaves that are coming out of each node, and they grow on the same level, but on opposite sides of the stem. So that's why we call them opposite. And you can see in the example of this hornpot tree, so each and every level, if you think about levels like a ladder, there will be 2 leaves that emanate from that area, and they are opposite each other. The next example that you can have is clustered, and here you can see that the leaves grow in bundles or close groups, and they grow from the same point in the stem. So if you look at the puzzle bush, the example here, you can see there are clusters of leaves. So there are little groups of leaves, and they all grow from the same point. The next option that we have is rosettes, and these rosettes you will see are at the end of a branch or a twig, and they are spiraled. So that's why I say it can often be alternate. So think about the rose. If you think about the petals of a rose, they are spiraled at the end, and that's the exact way that these leaves are arranged. And the example, you can see the water matumi and the low-felt milkberry. The leaves are quite nicely spiraled. So you will see the picture that I show, the drawing, and also on the icon in the app, it's quite easy to see this type of arrangement. And the next one, the last one we're going to have a look at is world. And can you see the kamasi on the photo there? These leaves means that they are arranged in a circle on different levels. So at each node, you can get 3 or more leaves, and they are in a circle. In one plane, you get a whirl of leaves, and then in the next plane that Val now shows, you can get another whirl of leaves, and below that, you get another whirl of leaves. And just to show you here, we have shown you now simple leaf examples, but the same term applies. So you can have opposite simple and opposite compound leaves. So you will see that the compound leaves are also oppositely arranged. So they've got their leaflets, but each blade that is subdivided is also oppositely arranged. So when you look at your app, you will see when you've decided which type of compound leaf you're looking at, you will see that the arrangement is also selectable there. So this is both opposite leaf arrangement. Back to Val.
Thank you, Marie. Thank you very much. Now we're going to look at the overall blade, and we're going to talk about blade details. And remember that we said both simple and compound leaves are called blades, and we're going to look at those details. Now what we're going to do is fill in the details for a compound leaf. When you've got to choose a compound leaf, you don't want to have to measure and find the details for each and every separate leaflet. In simple, we're going to do the simple ones. It says leaf blade details. We did send out a letter, and we asked you each to bring a leaf with you. If you haven't got a leaf, just look around you, as I've done, and I've found a piece of paper, and you can use that as your leaf. And what we're going to do is we're going to take the leaf, pretend that this is the tip end, and this is the end where the leaf stalk comes in from the left, and you're going to fold that leaf so that the tip end of the leaf, the apex of the leaf, folds over and joins the point where the leaf stalk came in. And you're then going to put a really strong crease down that side where you folded it over, and it's now in half. For the next step, you're going to do the same thing again. You're going to take your crease, and you're going to fold your crease over to that point where the leaf stalk came in. So you've now got it in quarters, and you're going to crease really strongly so that when you open it out, you're going to look at it and find that you have 1, 2, 3, 4, 1, 2, 3, 4 segments and 3 strong creases. If you think of it as a fold in the middle here, and then this is my upper end, and then there's another fold there, the first detail we're going to ask you is about the upper quarter. The second detail we're going to ask you is about the lower quarter. So that's from your fold down to the lower end, which is where the leaf stalk came in, and this we call the lower quarter. And these can be very, very different shapes. They could be rounded, they could be halfway rounded, halfway pointed, or it could actually be flat. Same in this, it could be like a heart shape, it could be much more tapering. And all of those are vital bits of information that you can enter into the app. Now, one thing we want to be clear about is don't confuse the upper quarter with the actual tip. the extreme tip. Those tips have very specialized information. They can sometimes have little thorns on the end. They can be bent backwards. They can be elongated into a long drip tip. That's also incredibly important information about your leaf. So you've got an extreme tip, upper quarter, and lower quarter. If we now go to compound leaf and we look in the top right-hand corner, we see that this is a full app version and it's on 1399. Now, if we tick on compound, we find immediately it's come down to 329. Did you remember how many we said were simple? 870. I'm sure every one of you shouted that out. It's a very different story to have 329. And as I've said, those 329 have more information than the simple leaves. And here we've gone past our home screen and we've gone on to our tree search. Here is status on that tree search. And if we click on status, we find that the top bar is indigenous. And we want to click on that. Now, this is actually taken from Plettenberg Bay. And I've now clicked in Plettenberg Bay on only 73 compound leaves. And by clicking on indigenous, it immediately comes down to 51. We actually only have 51 indigenous trees in the Plettenberg Bay area that are a compound leaf. Back now to the full number. We've left Plettenberg Bay and we're at the full number. Now, if you read these words here, these first three, talk about those kind of compound leaves we've already shown you in that evolutionary development. There's once divided like, there's once divided not feather-like, and then there's twice divided feather-like. If I click once divided not feather-like, because we've dealt with the once divided feather-like very nicely, and you learned that there was one that's got a pair of leaflets at the end and one that's got a single leaflet at the end. So let's have a look and see what this one means, not feather-like. And we tick that one, and then we find these are the options available to us. None of these look feather-like. Once divided compound, but not feather-like. And the options are 2 leaflet compound. And those of you who are very smart are going to clap and say, yes, she showed us Mapani. There's 3 leaflet compound. And then there are a lot of 3 leaflet compound that are all rissas. And we're not going to go into that right now. You'll get to be familiar with that once you use the app. So it's really 2 leaflet, 3 leaflet, and then hand-shaped. And here we have 6 different variations of hand-shaped with different numbers of leaves. We're now going to go back to that screen and remove that tick and look at the once divided feather-like and do that in more detail. So you had once divided feather-like with a single terminal leaflet. And here it is, the little red picture. I'm back to Prof. Balkwell. Just learn to look carefully. Don't panic. Don't think, oh, this thing's so hard, I don't understand it. It says single terminal leaflet. There it is in red, and it's showing you that that is a leaflet. Pair of terminals showing you that they're 2 together. So we're now going to the single terminal. We're in South Africa. We've got 135 trees that are once divided feather-like. That's not a lot. We're now examining single terminal leaflet. You've got 1, 2, 3, 4 options of what you do first. This one at the top, the leaflets, the number of pairs, excluding the terminal. So this here would be 2 pairs. That will give you the most dramatic change. Let's just look at a few examples before we actually enter anything. Here's a false Marula Lania, Lania schweinfurtii. And you can see that's got 2 pairs, excluding the terminal. Your yellow bells, which is an alien, invasive, Tacoma stands, Odequum Pumalanga, is completely and totally overrun by this terrible plant, which is why it's worth showing you. So your yellow bells has got 1, 2, 3, 4, 5 pairs of leaflets and the single terminal. Your showy Calpurnia has 1, 2, 3, 4, 5, 6, 7, 8 pairs and the terminal on the end. So when the app asks you how many pairs of leaflets on your particular leaf that you're looking at, you enter that. Now here, I had a look at the species that we had. We looked at the basamas and thought that they were quite interesting. And so we entered 5 onto this little thing. It comes up here, leaflets, excluding terminal, and it's number 5 pairs. When we entered that, it very cleverly tells you what you've entered. When you go back to your single terminal, it reminds you that you've done 5, so you can't get lost. And then when we have a look, if you remember just now, there were 3 basamas, and now we've gone down to 64 trees, and there are only 2 basamas left. So when I looked up in the information, the other basama, which was glossy basama, is only 1 to 4 pairs of leaflets. So it got dropped when we entered 5. And we're now diving down quite fast. It's almost like a game you're playing, and you're at 64 trees. So we've done the leaflets, the number of pairs, and we're now doing blade, the largest leaflet. Or if you remember back to a few minutes ago, either the largest or the terminal. What comes up is this very complex screen. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9 different options. I suggest we go to sizes. It gives you the biggest jump, the fastest, and it's very easy to enter. What comes up is that you can enter the length. If you click on this little box here, you'll be given a ruler, and you place your leaf on the edge of the ruler. The leaflet that we've got is 55 long, and it's 33 wide, and the leaflet stalk is 15. And when we enter that, do you remember we were on 64? And now, having entered that, we're on 11. Now when we look, we've got only 11 species left. You could go further. I'll show you some more things you can enter. But quite honestly, by this stage, I have to just scroll, because you can very quickly see, if you look at that top leaf, is that looks totally different from that. This one's got rounded edges. Your eye will really rapidly start to learn. Even by just looking at these pictures, you can decide which one it is. Or, you know, from last week, if you click on this, you will get an option of information, and you can go and check the information. So that's in the largest leaflet or the terminal leaflet. Another very easy one to do is the edge or the margin. And you're offered only 2 options, that serrations are absent or they're present anywhere on the margin. And we can see here the African white stickwood. Here are the teeth. Marie, I hand over to you to Thorns.
So the next valuable and easy to spot tree characteristic is thorns. And you will also see in most field guides, they divide the leaves simple and compound, and then they go to arrangement, and then they add thorns. So thorns is a very valuable characteristic to use. And because our search function is in any order, I definitely suggest to even add your thorns first. So when you start with a search, add the thorn information, and you will see that the numbers will drastically reduce. The thorns are found at the bottom of your tree search ring. So there is the button for thorns. And if you click on it, you will see that there are a few options, 4 options. The one is completely absent or present on woody parts, and that represents 217 trees only. And then present on leaflet parts, 29. Present on succulent looking stems, if you think about islands, only 37. And remember, we haven't even added location yet. So this is a very powerful way to drastically reduce your numbers. We are first going to look at those present on woody parts. You will see we are going to look at thorn shape. Can you see there's a few options here so that you can explore that on your own? Really powerful stuff to help you to reduce your tree number. So when we look at thorn shape, there are again a lot of options, and you will think about acacias in the first and the second one. We are going to look at both straight and hooked and 2-pronged. So the first one that I'm going to show you, straight and hooked. Can you see when you've clicked on that, only 11 species, and then that's even without simple leaves. Can you see that the example we have here of the buffalo thorn, that's got 1 straight hook and 1 hooked, and it's at the base of the leaf attachment. So can you see very easily a way to reduce your number of trees? The next example that I will show you is two-pronged, and can you see only 9 trees? And there is the example of the bushveld num again. So a very easy way to quickly reduce your tree numbers if thorns are present or not, and even saying thorns are absent. So now we are looking at thorns on leaflet or leaf parts that are not succulent. Can you see there's 2 options, succulent and not succulent? So can you see only 20 species? And if we look at those on compound and central featherlet shaft, have a look at that very nice picture of the dwarf coral tree where you can clearly see that it's got thorns on the leaf shaft and the featherlet shaft. And then the last example that I want to show you is succulent leaves. And if you think about an aloe tree, that's the most common one that you can think about. And can you see there the teeth and a very useful characteristic to add? And you see the example there, aloe-like thorns on leaves. And very important, like I said previously, you can combine these characteristics. If you combine it with the location or with the leaf shape or the type of leaf or even the flowers, you will very quickly get to a positive identification.
Right. We've enjoyed that. It was a lot to cover, a lot for you to think about. We're very grateful to all these people who have given us permission to use their photographs in the app. So we've used them here now. And I think we'll call our Shane back again and handle questions. Thank you for all listening.
So the first question that I've got is from Farah. I took some pictures and later I saw my photos under the already uploaded photos. I was very surprised. Do these photos get moderated and are they available for everyone? P.S. I do not mind at all as it shares knowledge, and I also sync the sightings to the cloud.
Very good question. So this is where Farah had a sighting. He clicked that sighting and then he took photographs on his own app, and then it's a fantastic feature. That photograph pops in at the end of the images that are already on the app, but just for you, Farah, not for the rest of us. We can't see them. We never will be able to see them. And if you want to delete them, you have to sightings to delete them. But they help you when you're looking at whatever plant and you saw it once more. There you are. You've got your own pictures as well as ours in the app. I think that's a wonderful feature. It's very exciting.
Yeah. But if you are very pleased with your pictures, you can definitely send them to us, and we can think about adding them to our app, yes.
If you've got a flower and we don't, then we'd absolutely love it if you sent it to us, and your name will be on it. Thank you. Good question.
Okay, lovely. Thank you. Here's one from Eleanor. What is the evolutionary benefit of subdivided leaves as opposed to simple leaves?
Yeah, I'm not absolutely 100%, but what I can think of now from the top of my head is, especially if you think about certain environments, a big simple leaf will, the water loss from that leaf will be immense. So oftentimes if you think about desert areas, there's typically acacias or Senegalias or Vachellias, and they've got small leaves, and that is to help the tree to reduce water loss, because they've got the stomata at the bottom of the leaf with the transpiration and stuff that they need for photosynthesis. The bigger the leaf, the bigger the water loss. So especially, and I think that this might be the main answer, is in very arid conditions or wherever the tree is adapted to, and that's why needle-like leaves, and they've often got a waxy layer as well to help reduce water loss. That is definitely the benefit of having those small leaves, is to help reduce water loss.
I'll just add quickly that acacias actually fold up at night, and then that further reduces the loss. If there was a wind flapping a big leaf around, exactly, Marié, it would lose a lot of water, dry out quickly. But if the little leaflets fold up next to one another, close up, then there's surface areas incredibly reduced. Lovely question. Thank you.
Yeah, the reset question. Can you quickly talk about how to reset a search or go back if you've chosen the wrong selection? So what you can see when you go into your tree search ring, there will be a big reset, a round circle in the middle, and also at the bottom, you will find there is an option to reset. And if you are in a tree search, if you in your tree list, at the top right-hand corner, there will be a magnifying glass. So on the one side is the home button and the other one is the magnifying glass. And that's where you press to get back to a tree search. And also, if you're inside the tree search, you will see there's options that will see completed done when you click on that at the bottom, or that little arrow to the left where you can press, and that will also go back to the tree list. The tree search. And if you go to your home screen, if you do not reset your tree search, then that's always, then whatever you've selected is still active. So then you can go out and inside the tree search again and then change the answers there or whatever. But reset is in the middle of the tree search ring, and also at the bottom you will see there's a button to press reset. And then to know that it's clean, you will see it will say all of South Africa at the bottom and have the full tree list, the number of trees at the top.
The other thing to add is bottom right-hand corner, when you're in your tree search, there's a little button that says review. And if you press review, what comes up is every single step that you entered. It tells you what you entered and the number that you entered, or the box that you ticked. And those have all got crosses next to them. So you might have already done 16 or 5 or whatever number of items. And they've got a cross at the end. And if you click on that cross, it'll remove that option. So if you weren't sure if the flower should be clicked as yellow or white, and you chose yellow, and then you don't get the right answer, you could unclick yellow, and then you go back to that and you enter white as an option. So that review button helps me very, very often. It's instead of going right back to the beginning and starting again, often in the review, I might have as many as 12 entries, and I just go review, remove, 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 remove with the X's. And then I go back to my tree again and I pick up from where I stopped reviewing. It's very, very useful button.
And then a very quick question. What's the difference between a tree and a shrub? The general difference between the two is a tree has got one main trunk and the shrub is multi-stemmed. So it's got a lot of stems going out from the base. But depending on where your tree grows, or if it's been cut down and it's made new shoots at the bottom, then it will look like a shrub, but it can actually be a tree, and it has to be grow higher than 3 meters. And then the last question there we have, are thorns modified leaves or stem? That's a very good question. It can be both. A thorn can either be a modified stem or it can be a modified leaf. So we can quickly show that in the next session. We might, if we have time, we will show you. But thorns can be a variety, and thorns can grow either just from the outside where you can easily prick them off if you think about a rose bush, or it can be from a stipule, that's an attachment at the base of the leaf. So thorns can come from various sources.
Thank you, everybody, very much indeed for attending. Thank you, Shane, for all your organization. Thank you, Marie, very much indeed.
It's a pleasure. Thank you, Val and Marie. Absolutely fabulous again, writes Molly's. Thank you for that. Thank you all. Looking forward to next week. All the best from Farah. Thank you, Farah. You're really just cheering us on. That's awesome. Sarah writes, thank you. I found this incredibly interesting and informative. Thank you for that, Sarah. That's wonderful. From Muffy, thank you. These sessions are fun and informative.
Muffy's in Canada. Thank you, Muffy.
Oh, there we go.
She entered a lot of the botanical captions for us on the photographs. Muffy, thank you.
Thanks, Muffy. I'm not even going to ask you what time it is over there, because I know it's probably not really.
Amazing.
I think it's supper time. All right, lovely.
Thanks for running over. Thank you.
Okay. All right. Thanks, everybody. Take care. Have a good evening. Cheerio.
Thank you very much indeed.
Thanks.
Night. Night, night. Thanks, Marie.
Bye.